All right, my friends, we've finished up our initial implementation of our login form using stateful widgets throughout our entire application. We're now going to start the process of rebuilding the application, but instead using this block pattern thing. Now, before we dive right into this block pattern, I'm going to throw a little detour in here. So this might be a little bit unexpected, but before we can visit this block pattern thing, we're going to have to learn a little bit about a feature of Dart called streams. So we're going to do a quick aside. We're going to look at a couple of examples all about streams, and then we'll come back once we have some better knowledge of how they work, and we'll start implementing this block pattern thing. Now I'm going to tell you right now, streams are what make this block thing complicated. So that's why we're doing this quick aside, to make sure that you get a really good idea of how streams work and what they're used for, and then we can come back and really understand how this block pattern works. So quick pause right now, come back to the next section, and we're going to start talking about streams in Dart. In this section, we're going to start to do a quick aside and talk about streams in Dart. So let's get to it. We got a lot to learn. All right, so first off, a definition of sorts. So this is coming straight from the Dart official documentation on streams. A stream is a source of asynchronous data events. And if that doesn't make any sense to you, yeah, it doesn't really make any sense to me either. So I gotta be honest with you. I want to level with you. Streams are not the easiest thing in the world to understand. So we're going to first begin by taking a look at a rather in-depth analogy. We're going to consider this analogy. We're going to talk about it a little bit and a couple different odds and ends around it. And then we're going to write some code to get a better idea of how streams work. So without further ado, let's talk about a quick analogy. Once we understand it, we'll then come back to this idea of streams. Okay. So here's the analogy. I want you to imagine that we are building a chocolate cake factory. So this is our factory right here. That's supposed to be the roof, I guess. Inside of our factory, as you might guess, we're going to create chocolate cakes. Now our factory is a little bit special. When we say that this is a chocolate cake factory, we really mean chocolate cake. So if someone comes to our factory and they ask for like a cherry cake, or I don't even know what other kind of cakes there are. I don't have cake that often. I wish I did. But if someone comes and they're asking for anything else, sorry, we can't help you out. Our factory specializes only in chocolate cakes. So we're going to do a little bit of interactive diagramming here, and we're going to walk through the process by which our factory might work, okay? So I'm going to be pulling up a couple of elements here over time. I'm going to first start with this one here on the left. So I'm going to pull it up. Here we go. Okay, so I want you to imagine that our factory doesn't really have any remote offices or anything like that. And if people want us to make cake for them, they have to come directly to us. And they have to fill out a little form that says that they want us to bake a cake for them. And on that form, they have to specify the type of cake that they want. So this customer is going to walk up to our factory, up to the front door right here. They're going to take their form, and they're going to hand it off to this person that we're going to call the order taker. So the customer gives this order to the order taker, like so. The order taker is kind of a nobody. They don't do a whole lot. All they do is literally receive that piece of paper that says the kind of cake that we need to make, and then they hand it off to the interior of our factory. So the order just comes in through the door through this order taking person. Now, as soon as that thing comes into our factory, the order is going to be handed off to someone that we're going to call our order inspector. So this order is going to be taken from the order taker. They're going to hand it off, and it's going to go directly to our order inspector. Now, the order inspector's job is solely to look at the order and pull off the one important piece of information that we care about on this order. We don't care about who the order is for. This person doesn't care that it's for this customer. They don't care about the size of the cake. They don't care about anything. All they care about is pulling off that one very critical piece of information, and that is whether or not this is an order for chocolate or some other kind. Now, this order inspector is not going to actually look at that type and say, oh, this is not chocolate. Sorry, we can't help you. All this person does is pull off that one property and say, hey, here's the type. Okay, I got it. I got the type off the form. Now, once this order inspector has that type, they're going to then pass the order off to our lead baker right here. So here's our lead baker. So the order type is going to go off to this baker. And now the baker is the very important person inside of our factory. The baker is going to receive just that type property right there. And the baker is going to look at that type and it's going to say, okay, let's see, is this thing asking for chocolate cake? Well, if it is asking for chocolate cake, great. Our baker is going to create a cake. Here's your cake, brand new chocolate cake. But if it's not asking for chocolate, if it's asking for like a vanilla cake or, I don't know, sponge cake, whatever else, I don't know, whatever other types of cakes there are, then the baker is going to say, you know what, I can't deal with this. No, I can't make this cake. I'm just going to say this is an error. Sorry, I can't make your cake. Get out of here. Go find someone else to make your cake for you. Now, whatever happens, we're going to definitely need our customer to come pick this order up on the other side. You know, the customer eventually wants to get their cake, whether or not it's a cake or there was some error during that entire process. So on the very other end, we're going to have something that we call a pickup office. So either the error or the actual cake will be thrown off to this pickup office out here. And then out there, it's going to be up to our customer to come back around and attempt to pick up the cake or the error. And if there's an error, the customer might look at it and say, oh, oops, I guess I made a mistake here. Maybe I need to try creating another order. Or if it's the cake, great, then the customer gets their cake. Okay, so that's our analogy. That's everything. Let's take a quick pause right here. We're going to come back to the next section, and I want to point out a couple of very interesting items about this process. After we discuss the analogy a little bit, we're then going to write out a little bit of code to model this entire cake factory using streams. So quick break, and I'll see you in just a minute. In the last section, we spoke about streams through this chocolate cake factory analogy. Now, I want to point out a couple of very interesting items about this chocolate cake factory right here that weren't necessarily covered in the last section. So these are just some insights that I have about this chocolate cake factory. After we talk about these insights, we'll then start to write out a little bit of code to model how this chocolate cake factory works. Okay, so here's some insights or characteristics. I just got a couple. We'll go down it pretty quickly. So the first thing I want to talk about here is that it's very clear that there's kind of an order of operations here. There's kind of a sequence of steps that an order goes through when it enters our factory. The factory receives an order and then clearly does some amount of processing on it. Like we had several people in here, like our order inspector, who kind of just took off one very important piece of that order. And we had the baker who took that type of cake that was supposed to be created and turned it into some other type of value. So clearly this factory is doing some amount of processing on a given value, and then it's kind of spitting out a new value on the other end. The next thing that I want to point out here is that the factory is not built when the customer first comes up to it. So when our customer first walks up to the order taker over here on the left-hand side, we're not creating the factory the instant that this customer shows up. Instead, we build the entire factory, and then it just kind of sits around and waits for some given customer to walk up and hand off an order. Now, that might sound like a very small distinction, but again, just bear with me for a little bit. Now, in the very same vein, it's clear that since we are building this factory ahead of time, the factory might have to spend a lot of time just kind of sitting around, twiddling its thumbs, waiting for an order to come in. After that factory has processed an order, we don't throw away the entire factory. Instead, we can easily reuse it for another order that comes in the future. And that might be at some long point in the future. There might be a long time that we have to wait before another order comes in. But as far as the factory is concerned, that doesn't matter. The factory will sit around and wait for as long as it has to for some new order to come in. Now, the next thing I want to point out here is that someone clearly had to stand around out front of the factory and wait for an order to come in. And that's kind of the entry point into our factory. And so in the diagram over here, that was our order taker. When the customer came up, they didn't just take their order and throw it through the front door and pray that someone picked up the order. Instead, the customer handed that order off to this very dedicated order taker. And the order taker was responsible for taking the order and passing it off to the next step inside of our factory. Okay, last item here. So after that cake is made, someone has to actually come pick it up. So over here on the far right-hand side, we had our order office, or the pickup office. So after that cake was created, or there was an error, the result got handed off to this pickup office. And someone had to come here and actually deal with the value that was spit out of our factory. We didn't just kind of like spit the value out into nothingness. Obviously, someone wants the cake that is created. Or alternatively, someone might care about the error that occurred while we were trying to create that cake. So I would say that on either side, there's clearly some like handoff step, and there's clearly some pickup step as well. All right, so that's it. That's just some very quick items I want to point out about our chocolate cake factory. So now that we've got a better idea of the overall analogy, and I've highlighted a couple of steps along the way, we're going to come back to the next section, and we're going to write out a little bit of code in Dartpad to get a better idea of how we might implement this chocolate cake factory using streams. So quick break, and I'll see you in just a minute. I think we've now got a pretty good idea of how our chocolate cake factory works. So we're now going to flip on over to a new Dartpad instance and write out a little bit of code to model our chocolate cake factory using streams. So to get started, I'm going to first flip on over to Dartpad inside of a new browser tab. Quick reminder, you can get here by going to dartpad.dartlang.org. Then once over here, I'm going to first get started by declaring my main function. And right above that, I'm going to import one library called import Dart async like so. So the async standard module that comes along with Dart contains all of the code related to handling and creating streams. Now before we write any stream related stuff inside of here, I'm going to first declare two classes that are going to represent the different entities that exist inside of our little chocolate cake factory right here. The first class I'm going to make is going to represent the order that a customer takes and hands off to our order taker. Then the second class I'm going to make is going to represent the completed cake that gets thrown out the other end of our factory. So back inside of Dartpad, I'm going to first make my class cake. Now this class probably doesn't really need any properties associated with it, so I'm just going to put down a set of curly braces like so. And then I'll also make my class order. Now the order definitely is going to have a property associated with it, probably the type of cake that we want to have our factory create. So I'm going to add on a string variable to this that I'll call type, and we'll create that order anytime we call create that type anytime we call the constructor for order. So I'll define the constructor, and I'll say this.type, like so. Okay, so we've now got a class to represent the cake and the order that we hand off to our factory. So now inside of my main function, I'm going to create a new instance of something called a StreamController. So I'm going to declare a new variable called controller, and that's going to be a new StreamController like so. Now at this point, you're probably thinking, Stephen, what's this StreamController? We've been talking about streams all this time. So let's talk about what a StreamController is very quickly. First, a quick reminder. Remember, outside of our factory, like outside of it, completely decoupled from everyone in the factory to a degree, was someone that we called our order taker. And anytime we had a customer come up to the factory, they took their order and they handed it off to the order taker. And then that person turned around and just threw the order into the chocolate cake factory. So with that in mind, let's talk about what our controller does for us. All right, so we just created a StreamController. When we make a StreamController, behind the scenes, we get two additional objects created for us automatically by the StreamController. And those two objects are assigned to two properties on the StreamController instance itself. One is called the sync, the other is called the stream. So the sync is our ability to add new data into our stream. So in our analogy, the sync right here would be like our order taker. It's the entity or the person who takes some new value and then just turns right around and hands that value off directly to the stream. So you and I do not manually reach into the stream right here and try to add values to it. Instead, we always use a sync to add values into a stream. Similar to how our factory worked. We didn't have our customer come up with the order and just throw it into the factory. The customer handed off the order to the order taker, and that order taker did something special with the order to add it in the correct fashion to our factory. So that's the purpose of our sync. And we only get the sync because we created the stream controller. Okay, so let's write out a little bit of code to create a new order and then hand it off to our sync that was created with our controller. So I'm going to say final order is new order. And for this first order, I will make it, how about a banana cake? I'll then look at my controller. I'm going to reference the sync that was created with it. And then to add a new value or to pass a new value into the sync so the sync can pass that off to the stream, I'm going to call the add function on the sync. And I'll pass my order in there, like so. Okay, so that's kind of step one right there. We have now created our order through our customer. You know, our customer doesn't really exist here. We're just pretending that there's really just the order. But we created that order, we hand it off to the order taker hands the order off to the stream. So let's take another quick pause right here. We'll come back to the next section and we'll start writing out the code for our order inspector. So quick break and I'll see you in just a minute. In the last section, we wrote out a little bit of code to create a new order and pass it off to the sync that was created along with our controller. So we can now imagine that our order has gone through the sync and the sync has passed it off to the stream that is tied to our controller. So we're now going to implement the next step, which is to make sure that our stream has some entity or some process in it that's going to inspect the order that it just received and pull off just the type property. That's the only purpose of the order inspector. It's just going to look at that type property and it's going to throw away everything else tied to the order. So back inside of Dartpad, I'm going to first give myself a little bit of space here. And then I'm going to reference the stream that was created with our controller. Because remember, when we make a controller, we get not only a sync, but we also get the stream. And the stream represents our factory. So I'm going to first write out controller.stream. So that's a reference to our factory. And then I'm going to call a function on the stream called map. So when we write out map, hopefully you'll see the little description right here. The map function is going to receive every element or every order that is added to our stream. Inside of this map function right here, you and I are going to pass a function. And inside that function, we get the ability to inspect every new order that comes across, and we can pull off just one distinct property or many properties, or otherwise somehow transform or change the order that's coming in through our stream. So inside this map function, I'm going to pass in a new function that's going to be called with the order that we just added. Then inside of here, I only care about the type property that is associated with the order. I don't care about anything else related to the order. We just care about that type property. So I'm going to return from here order.type, like so. So this step right here essentially is our order inspector. We receive the order inspector says all I care about is what type of cake we are trying to make. And so the order inspector receives a order object and it hands off just a simple string to the baker. So that's what's going on with this step right here. Now the next thing we have to do, next little piece of code we're going to add in here to model our baker is going to be pretty complicated. So let's take another quick break. We'll come back to the next section and write out the code for our baker. In the last section, we wrote out some code to represent our order inspector. The inspector is going to receive every order that comes into our stream, pull off just the type, and then pass it on to the next step, which is going to be our baker. So the baker code that we're going to write is going to be a little bit more involved, but at its core, it's doing exactly what you see in this diagram right here. The baker is going to look at the type that the order inspector just passed off, so it's going to be a simple string, and it's going to check to see if that string is equal to the word chocolate. If it's equal to chocolate, then great, we're going to make a new instance of a cake and pass it along to the end of our factory. If that string is not equal to chocolate, then we're going to say, sorry, can't do it, and we're going to instead create an error and pass along that error. So let's write out the code that's going to represent our baker. All right, so right above our controller.sync.add right here, I'm going to declare another new variable called baker. So again, the code for this is going to be a little bit more complicated, but at its core, it's really not that crazy. It's just a little bit of syntax. So I'm going to write out new stream transformer dot from handlers, like so. Then inside of here, I'm going to add one named property called handle data. That's going to be a function. The first argument is going to be whatever we received from the previous step of our stream. So in the last step that we just went through, we pulled off just that string type property from our order. So now that type right there, because that's what we returned from this map, is what's going to be passed into this handle data function right here as the first argument. So I'm going to label this first argument as cake type, like so. Then the second argument to this thing is going to be our sync. So remember, our sync is what takes a value and adds it into our stream. All right, so now inside of this function right here, we're going to inspect the value of cake type. If it is equal to string, then great. We're going to add it back into our sync, which allows this value to continue flowing through our string. So, allow the value to keep continuing through our stream, not string. So inside of handle data, I'm going to say if cake type is equal to chocolate, then we're going to do sync.add, and we'll create a new cake, and that's what we're going to add to our sync. So now this little piece right here represents in our diagram this kind of flow right here. So because the previous step produced a value of chocolate, we're going to create a new instance of cake and add it back into our sync, which is going to cause the value to essentially continue along for the rest of our stream. And in this case, end up inside of our pickup office, which we're going to implement in just a second. So now we'll also add the code in to handle the case in which we got a string that was not equal to chocolate. So back over here, inside my if statement, if it's not equal to chocolate, I'll put on an else case, and I'll do sync.add error. And then as the first argument to add error, I'm going to write in a string of why, or exactly what just went wrong. So in our case, we'll just say something like, I can't bake that type, like so. So we've now created our baker, but you'll notice that he's kind of a standalone step right here. We created the stream transformer thing, and we assigned it to baker, but we've not yet wired up our baker to any part of our stream whatsoever. So to make sure that our order, or the order type, eventually gets to our baker, I'm going to add on another little step to my stream down here. So after I call .map, I'm going to call transform, and I'll pass in the baker, like so. Okay, so that's the baker step. Now let's take another quick pause. We'll come back to the next section, and we will implement the code for our pickup office. So quick pause, and I'll see you in just a second. In the last section, we added in some code to represent our baker. And then we added that baker to our stream. So now anytime a new order is added to our stream, we first extract the order's type. We then run the order type through our baker, who's going to either produce a new instance of a cake or add an error. So now the last thing we have to do is add on a final step to our stream, which is going to represent our pickup office, where a customer can come up and somehow pick that newly created cake or deal with the error that was generated. So to add in our pickup office down here, I'm going to chain on one last step called .listen. Now, the listen function is going to take two functions. The first function that we add to this is going to handle the good case, the case in which we successfully created a cake, and that cake is now ready for pickup by our customer or whoever else. So inside of this first argument right here, I'm going to create a new function that's going to be called with our cake that was just created by our baker. And inside of here, I'm just going to print out something that says like, hey, here's your cake. And we'll do a little bit of string interpolation to print out the cake itself. Then as a second argument to listen, so notice that I've got my comma in here at the end, as the second argument, I'm going to add in a named property called onAir. OnAir is going to also receive a function, and this thing is going to be called with the error message that we created inside of our baker. So sync.add_error right here, we return the string that said I can't bake that type. So that string right here of I can't bake that type is going to show up as this error argument down here. So in that case, we'll just print out the error that we receive, like so. Okay, and that's pretty much it. That's all the code. So let's do a quick test right here. We're going to make sure this thing works, and then we'll talk about how all the code we just wrote really lines up against the analogy that we just put together. So I'm going to click run. And as a quick reminder, with this first cake that we added in, we were creating an order type of banana. So in my console over here, you'll notice that I have an output of I can't bake that type, because we have a type of cake that our baker doesn't know how to deal with. So I'm now going to try replacing banana with the cake that we do know how to deal with, a chocolate cake. And I'll run this. And now I clearly see, okay, cool, here's our cake. It's a cake of type cake, or instance of cake. You get the idea. And if we change the order type to anything else besides chocolate, then we're always going to see something that says, sorry, but I can't bake that. And so once that finishes up, come on, taking forever. There we go. I can't bake that type again. All right, so clearly our code works to some degree, and it at least somewhat models our cake factory here. So let's take a quick pause. We'll come back to the next section, and we're going to walk through all this code one more time and talk about how it all relates to the analogy that we've been talking about for the last couple of videos. So quick break, and I'll see you in just a minute. In the last section, we finished up our first example of writing out some code that used streams. We're now going to do a quick overview or review of all the code we just wrote. I also took the diagram that we were working with before and cleaned it up a little bit and added in some comments. So let's do it. I'm going to zoom in and go to the far left-hand side. So everything started off when we first created our order instance and then passed it off to our order taker. Now in reality, the order taker was the StreamController.sync.add function. That add function is how we add new values into a stream that we have created. So the add function essentially took that order and threw it through the front door of our stream. And then the stream started to process that newly created order. Let's go back over to Dartpad and find the line of code where that occurred. Okay, so back over here, down towards the bottom is where we called add with the order. One thing I want to mention here is that you'll notice that the process of adding the order was 100% decoupled from the process of setting up our stream. That kind of ties back into a note that we discussed earlier about our factory. So one of the characteristics we said that a cake factory has is that the factory was not built when the order was made. Instead, we made the factory at a different point of time, and after the factory or the stream was created, we could then add in as many orders as we wanted to over time. Okay, so back to the diagram. So the order came through our front door, so to speak, and went off to our order inspector. The order inspector's purpose was to just extract the type of cake that we wanted. And so that was, in this case, a string of chocolate. The order inspector was implemented by using the map function that is tied to our stream. So that looks at every event or every value that comes into our stream, did some processing on it, and then returned whatever value got extracted. So inside of Dartpad, that was our map function right here. We took in that incoming order, we extracted off the type property from it, and returned just the type property. As a quick reminder, when we use this arrow function right here, we get that implicit return. So you can kind of imagine that there was a return keyword right there to return just the type. Okay, so we get just the string of chocolate and we pass it on to the next step, which was our baker. So the baker was implemented by creating a stream transformer. That stream transformer takes incoming values, does some computation on them, and then has the ability to add more values back into the stream. Now, one thing I want to mention here is that the stream transformer appears to be very similar in nature to the map function that we used in the step before. In both cases, we did some processing on an incoming value, or that incoming order, and then returned a new value. The big difference between the map function and the stream transformer is that with the map function, we have a 1-to-1 ratio of incoming events. So in other words, we have one value coming in, or one order, and we then returned exactly one string. With the stream transformer, we technically have the ability to have one value come in, and then we can actually call add multiple times inside of our string transformer. So here's stream transformer right here. When we added in the newly created cake, we had called sync.add. We could call add multiple times if we wanted to inside of here. And so we essentially just get a little bit more flexibility with the stream transformer than we do when we make use of the map function down here. But in essence, they're both used for processing incoming values. So the stream transformer's purpose was to look at the incoming type of cake that it needed to create. And if it was equal to the string chocolate, then we created a new instance of cake and returned it. Otherwise, we created a new error. Now, in both cases, we produced a value, and I used the word return, but that's not exactly correct. Instead, we used this sync object right here. Now, one thing I want to mention about this sync object is that it's not technically the same sync that we use down here with our controller. So this sync right here kicked off the entire start of our stream. It was kind of the first step of adding values into the stream at the very top up here. The sync that we get access to right here, if we call sync.add with this thing, it's a separate sync that adds a value kind of like right here or so. So when we call sync.add inside the transformer, it doesn't start the entire process over again. It just adds a new value that continues on from the transform step forward. Okay, so whatever happened, whether we called add or add error, everything ended up inside of our, so to speak, pickup office, which was really that listen function. The listen function ties into a stream, and it gets called with any values coming out of the stream. The listen function is our primary location to take data that is coming out of a stream and somehow interact with it, or somehow do something with the data that's coming out. So in our case, we had an initial argument, or a first argument right here, of just a function. This first function was called with any normal, reasonable values that were coming out of the stream, or any non-error values. We also had the named property of onAir right here, which was a function that would be called anytime we added specifically an error value to our stream, which was the case inside of our stream transformer right here with the sync.addError function. Okay, so that's a quick overview of everything we just did. Now there's still a lot more to learn about streams, so we are going to walk through a couple of other examples. But before we do, there's one last quick thing I want to show you. So in a new browser tab, I'm going to navigate to the Dart API documentation, which is at api.dartlang.org/dev. And then once here, we can look at the Dart async section, which is where all the classes that we just used are documented. So inside of here, you'll find the documentation for StreamController. So here's the StreamController class. You can read through the documentation right here very quickly if you want to. We could also look at the stream class, which is the actual stream that we used. There's some really good documentation on here as well that you might want to glance through very quickly. If you scroll down to the method section, you'll also find where we made use of the map function right here. So here's map, here's the listen function. You might want to take a look at some of the other things that are inside of here as well. And then finally, you might still want to look at the stream transformer class as well. So this was essentially our baker of sorts. And so you might want to very quickly read through this documentation. I'm not going to refer back to the documentation terribly often with a lot of the stream stuff, just because if we look at the documentation with every different function we're using, well, we would just be looking at documentation all day. So I do encourage you to keep this documentation open and maybe glance at each function that we're making use of, just so you can get a better idea of how it's documented over here. Okay, so good review. Let's continue in the next section. I do want to make one or two small changes to our chocolate cake factory over here, and then we'll also take a look at some other stream examples. In the last section, we did a big review of all the code we just wrote for our chocolate cake factory. Now at this point in time, you might be a little bit confused about the stream stuff because you might be thinking, Steven, we just wrote out a lot of code to essentially check to see that we are passing in a string of chocolate to like some thing right here. In other words, you might be thinking that we could have just implemented all this stream stuff by instead doing something like var order equals new order with chocolate, and then writing out something like if order.type equals chocolate, then create a new cake. Well, yeah, this kind of more or less is what we just wrote out with all of that very laborious code. This is really the core of what we just did. So the example we just did was really just meant as an illustration. So I now want to give you a more practical example of how we can do some things with streams that are otherwise very challenging to do without them. Okay, so here we go. I'm going to first get started by highlighting all the code inside of Dartpad. Now, if you want to back up this code, you can paste this or copy this all out and save it somewhere else. Otherwise, we're going to delete all this and start from scratch. So I want to create a new little application using streams. And we're going to largely just kind of write out the code for this, and then we'll talk about what it's all doing. Okay, so I kind of just write out the code first, and we'll talk about what it's doing. So inside of Dartpad, we're not only limited to writing out Dart code, we can actually write HTML inside of here as well, and then manipulate that HTML with Dart. So for this next example, I'm going to flip over to the HTML section, and I'm going to write out a button tag over here. And I'm going to give the button tag the text click me, like so. So now I should be able to go over to the right-hand side up here, click on HTML output, and I'll see that button appear. So we can now write some Dart code that's going to find this HTML button and allow us to kind of interact with it in some fashion. I'm going to flip back over to the Dart tab, and then I'm going to import a standard module from Dart that will allow us to interact with this button. So at the top, I'm going to do Dart:/HTML, like so. I'll then define my main function. And then inside the main function, I'm going to write a little snippet of code to find this button and give us the object that represents the button itself. So to do so, I'll do final button element. I'll call the variable button. And I'm going to get access to that button by writing out query selector and then pass in button like so. Okay, so now we're going to create a little game here. Okay, we're going to create a game. The game is going to be you have to click this button at least once a second. So you see me, you can kind of see the graphic on the button. I'm clicking it, clicking it. If I ever stop clicking the button for 1 second, then we're going to print out a message that says you lose the game. All right, that's going to be the game we're going to put together, and we're going to make it using streams. So again, we're going to kind of just write out the code for this, and we'll talk about what it's doing. So I'm going to say button.onClick. On that, I'm going to chain on .timeout. That's going to be a function. As the first argument, I'm going to pass in new duration with seconds equal to 1, like so. And then as the second argument, I'll put in a named parameter of onTimeout. That's going to be another function that gets called with a sync. And I'll call sync.addError with too slow. Or we could do what I said, which was you lost. Then after that, I'm going to add on a .listen. As the first argument, I'm going to pass in an empty function that gets called with some piece of data or event. We're not going to do anything with that, so I'm just going to place the curly braces right there like so. And then underneath it, I'll do onError. That's going to be called with a error message, specifically this you lost message right here. And inside there, I'm just going to print out that error, just as we did before. Okay, so now I'm going to run this, and we're going to try playing this game, and we'll talk about what all this code does and why streams are so important to create a game like this. Okay, so now if I go over to console, you'll notice that it might say you lost right at the start. That's totally fine. I'm going to try clicking on the button, and I'm going to click it for some number of seconds, and then you'll notice that when I stop clicking it, we're going to see another message of you lost. Okay, so I'm going to click, still clicking, still clicking, still going. Now I'm going to stop right now. And after 1 second, you see that little dot right there. And so if I go back over, we see the message, you lost. So clearly, this code right here implements this neat little game, but the code might not be super clear. So let's take a quick pause right here. We'll come back, talk about how this code is working, and then we'll talk about why creating this game by using streams is so much easier than trying to write out normal code that you might be used to build a game like this. So quick break, and I'll see you in just a minute. In the last section, we started wondering why we would use streams at all. To answer that question, we put together this little game where we have to click a button nonstop, and as soon as we stop clicking it for at least 1 second, our console prints a message that says that we lost. Now, building this game using normal code and not using streams would have been far more complicated, but maybe that's not a good enough reason. So let's take a look at a couple of different diagrams that are going to explain to you exactly why using streams in this case is so advantageous. Okay, so with the first example we looked at with the chocolate cake factory, you and I manually created a sink, and we hooked that sink up to our stream through that stream controller. So in that case, we were manually creating events and pushing them into that stream. Because we were manually creating those events, it didn't really seem like there was a lot of benefit to this. But the thing to understand here is that there are a lot of cases inside of Flutter and Dart where that sink or that source of events is going to be provided by Flutter or by Dart, not by you and me. So there's many different opportunities or many different locations where we will be getting sources of information from Dart and Flutter that represent user input or some input from other source of information, and you and I interface with that source of data through a stream. And so a perfect example of that is this button right here that we just worked with. So in this example, we created the HTML button over here on the HTML tab. We then got a reference to the button, and then we referenced button.onClick. .onClick right here, you can click on it, like the actual word on click, and then if you look at the bottom right-hand side, you'll notice that this thing is called an element stream. Keyword there being stream, of course. So this is an example of one place inside of Dart where we are interacting with Dart, we're interacting with this button element through a stream. Every time a user clicks on that button, this stream right here is going to emit a new event or a new little piece of data. And the only good way that you and I have to work with that click event is through the stream that Dart creates for us. So that's a good example of why we care about these streams at all. It's a prime way in which we interact with Dart and Flutter. We're not only limited to working with those button elements. Another example of where Dart would provide a stream for us would be if we created an HTML input. A user typing into that input triggers change events on that HTML input. And so Dart, again, provides us with a stream. Every event inside that stream describes a user typing something in. And so you and I might take that source of events. We might set up some processing step where we look at the input or the value inside the input, and then we produce some validation message out of that. Another example of why we would want to use a stream would be, okay, well, series of buttons. That's pretty much what we're doing right now. One last one. Here we go. This is a good one. So another place where we might want to use a stream is when we create network requests. Now, we already created a network request before, and we got back a future from that, which remember is like a JavaScript promise. But we can also interact with network requests by treating them as though they were a stream that emits events like, say, a successful fetch of some data or an error message that might occur while we are fetching some data. And then inside the stream that you and I set up, we can add in little map functions or little transformers that take the data that we get back from the network request, parses it, turns it into a model instance, and that gives us back some parsed JSON data. Okay, so clearly making use of streams is definitely advantageous because there's many locations in Dart and Flutter where that is just the mechanism that we have, the sole mechanism we have of interacting with information that Dart is giving to us. But maybe that's still not a good enough reason to you. Maybe you're still thinking, Stephen, why would we care about that, right? Like, okay, Dart saying this is the only way we can interact with that? Why? All right, so let me give you another example. let's take a look at the application that we actually built right here. So in this application, like I said, we're watching this on-click stream, which is our source of events, and we chain onto that something called timeout right here. Now, if you click on timeout, you could definitely read the documentation on it down here on the bottom right, but I'll just show you a diagram to give you a better idea of what .timeout is doing for us. So first, notice that we're passing in a duration object right here that has 1 second tied to it. So let's talk about what this timeout thing is doing for us. Okay, so inside this diagram, we have kind of a time series of events, or a time series of clicks on that button. So everything starts over here at 0 seconds. So this is like when we first load our application up, and then we start clicking on that button. And so every box along here represents one button click. And so I was clicking pretty darn fast, like I was click, 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 click. And that is represented by every one of these boxes that you see on here. So in the first 3 seconds, I was clicking nonstop. So what that timeout thing does for us, back here, what this timeout thing right here does for us is it waits for 1 second to pass, and specifically 1 second because we passed in a duration here of 1 second. It waits for 1 second to pass without any event occurring. And if that happens, if we go for 1 second without any event, then this timeout thing right here is going to call this onTimeout function. And so inside the onTimeout function, you and I reference our sync, and we add an error in to say, hey, you lost the game. And that eventually went down to our listen function right here, which is where we pick up data that's coming through our stream, and we took that error and printed it out. So this example right here is another good reason of why we like to use streams. Building something like this with normal kind of procedural code, where we might put together like a for loop or something like that, would be exceptionally challenging. Maybe not exceptionally challenging, but definitely not the easiest thing in the world. When we implement this using streams, the code for it is rather concise and pretty easy to read. But if we tried to implement this with just classic procedural code without using streams, it would without a doubt be far more complicated. Okay, so let's sum up here really quick. Why do we like to use streams? Why is it so important to us? So first off, we like to use streams because a lot of pieces of functionality inside of Dart and Flutter will return streams that you and I have to work with. So we're going to interact with those streams to essentially receive data from standard library modules as a part of Dart and Flutter. We also really like streams because we can compose that processing pipeline out of easily reusable functions. And so in this particular example, well, we're not seeing anything too useful here, but at least back with the cake stream that we had previously, here's the cake example right here, we put together that stream transformer here to represent our baker. If we had other steps in some other stream where we had to check to see if a cake was of type chocolate, we could very easily reuse this stream transformer right here. In this case, we had just taken the baker, which was the stream transformer, and we passed it into that transform function. And so everything that we do around streams tends to be very easily reusable. Third, pretty darn easy to read the code that we write for streams and understand how they modify data. Now, the example I just pasted in here kind of reformatted everything, but if we very quickly reformat it, you'll notice that it tends to be pretty easy to kind of just read this from top to bottom and get a good idea of what's going on. So we're taking our source of data right here. We are pulling off the type property. We're passing that data to the transform of baker, and then we do something with the output. If we try to write the same thing or try to write our button example with some normal code, it would probably be far more complicated to read, a lot more challenging to understand. Now, the fourth item on here, this is where streams really go above and beyond not using streams. So streams are all about some asynchronous series of data, like a series of button clicks from a user. We don't really know when those clicks are going to occur. If we ever have to do anything related to time, or related to like timing a user clicking on something or pressing something, always a million billion times easier to do these time-related operations with streams than without them. Again, I kind of challenge you to write out this example without using streams at all. And I think you'll find that it's kind of complicated, or at least a little bit tricky. Okay, so that's kind of my case on why we're using streams here. I don't know, maybe you're convinced, maybe you're not. I think that we still could stand to get a little bit more practice though, so let's take one more pause and we'll look at another example or two of using streams inside of Dartpad, and we'll finally go back over to Flutter and start working with our block pattern using these streams. So quick break and I'll see you in just a minute. In this section, we're going to work on another little application, another little game of sorts inside of Dartpad to get a better idea of how streams work. This game is a little bit more complicated than the button one, so let's take a look at a quick diagram. Okay, so we're going to make a word guessing game. You and I are going to set a kind of secret word inside of our application. We'll then present our users with an input and a button. Our users are going to type in some guess at the secret word inside of here, like, I don't know, banana, and then they will click on the guess button. When user clicks on that button, we're going to look at the text inside that input, we'll compare it against the secret word, and if the user guessed correctly, then we'll print out a message telling them, hey, nice job, you guessed the word. To make the game a little bit more challenging, we're going to say that a user can only guess 4 times. So in other words, after the user clicks on this thing 4 times, that's it. They don't get to play anymore. Okay, so this one is going to be a little bit more complicated than the last game we put together. Let's first begin by taking a look at some documentation. I know I said that we weren't going to look at it too much, but we'll bend the rules here. We're going to look at 2 functions that are going to make putting this game together a lot more straightforward. Okay, so I've got my stream class documentation here. Remember, you can get here by going to api.dartlang.org. Then inside the stream class, I'm going to scroll down to the methods section. So here's methods, and inside of methods, I'm going to look up a function called take. So down, 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 here's take right here. So I'm going to click on take, and we'll take a look at the documentation for it. So we call the take method on a stream. When we call take on a stream, we pass in a count or an integer. When we call this, it's going to make sure that the stream is only going to process the count number more events. And then after we have received count events through the stream will then say, I am done, you can do nothing else with me. So to put that into diagram format, it kind of looks a little something like this. So if we called the take method on the button on click stream, and we passed in the number 4 to say that we only want to allow 4 guesses, then this is what we would have. Maybe when our application first boots up, the user immediately enters some text into the input and then clicks that button. And then maybe in this case, they get it wrong. So then they change their input, they click it again, still wrong, click it again, still wrong, and then after a little bit more thinking in there, they click it again. Now at this point, the user has clicked on that button 4 times. Because they've clicked on 4 times, and we called take with the number 4, the stream then marks itself as being done. When a stream is marked as being done, it can no longer receive any more data inside of it, so no more processing goes on. In addition, when a stream is marked as done, we can make use of that listen function that we used a little bit ago. I'm going to find the documentation for listen really quickly here. Here it is right here. So on the listen function, we made use of the onData argument right here. That's the first function that we've been passing into listen. We saw a moment ago that we can also provide a onAir function. We can also pass in a onDone function. And so if we pass in onDone to our stream, or into listen, after calling count or take 4 on it, then onDone will be called, and we can print out some message on there to tell our user that, hey, sorry, but you lost the game. Okay, so the other thing I want to mention is how we can somehow check to see if the user has entered the correct word. So we just saw how we can limit the stream to only allow 4 guesses, but to check to see if the user entered in the correct word, I'm going to again go down to the methods section, and under there I will find the where function right here. So with the where function, we can pass in a function to where. So that's going to be this test function that you and I are going to pass in. That test function will be called with whatever data is flowing through the stream. Then inside there, we can return a Boolean of either true or false. If we return false, then this event flowing through the stream will be discarded. And so in our example, let's say that a user clicks and makes a guess one time. You and I are then going to look at the value of the input, and if the user has the incorrect value inside there, we will return false from the where function. And that will cause this click event to kind of like drop out of the stream, and it will not pass on to anything else inside of the stream. Now, the key thing to keep in mind here is that the order in which we apply all these different functions definitely makes a difference. Because if we first call take, or excuse me, if we do the opposite, if we first call where on our stream, then we're going to be trying to discard items out of the stream, and we will not be kind of incrementing it against our max count number of guesses, as you'd probably expect. Okay, so that's kind of a description of the different functions we're going to use. So let's take a quick pause, and we'll come back to the next section and put this little application together inside of Dartpad. In the last section, we spoke about the implementation for a little word guessing game. So we're now going to put it together inside of Dartpad. To get started, I'm going to first add in an input element on our HTML tab. So right in front of our button, I'll add in a text input like so. And I'm going to change the button text over to something like guess instead. And then to stay true to the mockup that we looked at, I'll put a h4 on here as well with something like guess the word. Okay, so now back over on the Dart tab. So back over here, we still have our reference to the button element. That's good. We're going to also need a reference to the input element as well. So underneath the button, I'm going to create a new final variable. I'm going to mark its type as input element, and I'll give it a name of input. And then to get a reference to that input element, I'm going to write out query selector for input like so. So now with our button on click stream, we no longer really want to worry about timeout or the listen here. So I'm going to delete both those. So the first thing we're going to want to do here is attempt to limit the number of times the user can guess. So at most, I only want to take 4 events out of this on-click stream. And after that, we're going to consider the stream to be done. That's it, no more guesses. So to limit the number of times the user can guess, I'm going to add on take 4, like so. Next, we're going to look at that input and see if the value of the input is equal to the secret word. So I'm going to add on the .where function. This will be called with some event. Now, you and I don't care about this event argument right here. This event object right here represents the on click or the actual button click that the user did, but we're not really doing anything with the button click. We're just using this stream to trigger some code that we're going to run. So we don't really care about this event argument in this case. So inside the where function, we're going to look at the input, and then we're going to retrieve the value by writing .value. And then we'll check to see if that is equal to some secret word. And we'll make our secret word, how about just banana? So now, if any event or any data comes across our stream, we're going to look at the input. We're going to see if the value is equal to banana. If this right here is falsy, then this event that is coming across the stream is going to be thrown out, and we're just going to completely ignore it. But if the value is equal to banana, then we will allow the event to pass. So you can really think of where right here as being sort of like a gate of sorts. So then the last thing we want to do is add on our listen function. So I'm going to add on .listen. Now the first argument to listen is going to be called anytime a data event successfully flows through our stream. And so in our case, if something successfully flows through our stream to the end, that means that we've passed this restriction and this restriction. So that means that a user has successfully guessed the word. So I'm going to add in my function, and I'm going to print out, you got it, like so. However, if the user does not successfully guess in 4 tries, then the stream will be marked as done. So we can kind of hook into that by adding on an onDone function. And this will be called if the user guesses 4 times unsuccessfully and the stream gets marked as done. And so inside of here, we'll print out something like, nope, bad guesses. Okay, so let's try this out now. I'll click on run. Wait for it to load back up. There we go. So now I will first try to make the game fail. First off, you can see at the console we've got nothing over here right now. So I'm going to guess like blah, 2, 3, and then here's the last try. When I click on guess right here, that's going to use up my 4th try. So we're only taking the first 4 events out of the stream thanks to this take function. So when I click on guess, I'm going to see that little dot right here, which indicates that we've gotten some new console log. So I'll click on guess, I got the dot, and if I go over to my console, I see, nope, bad guesses. So in this case, we used up our first 4 tries. That caused our onDone function to be called, and that's it. We get no other tries. So I'm now going to run this thing again, and this time we'll try guessing the correct word. All right, so this time I'll do apple. Well, that's wrong. I'll do orange. Well, that's wrong. How about banana? All right, that's our word. So let's try this now. So I'll click guess, saw the little dot, and if I flip over, I see you got it. Okay, so just another little example of streams. Again, this is something where this might have been a little bit more easy than the timer game if we try to write this with normal code, but certainly with a stream, we got some pretty concise code going on here. You can kind of take a look at this and almost read it like English. Watch for a button click, only take the first 4 clicks, see if the input value is equal to banana, and then either print out you got it if we successfully guessed it. Otherwise, when the stream is concluded, we say sorry, but like your tries are out. So again, streams definitely improve this, in my opinion at least. All right, so 1 or 2 more quick examples of streams, because trust me, when we start adding streams in on top of all the Flutter stuff, life is going to get pretty tough. So the more kind of prep we do right now around streams, the better off we're going to be. So quick break, and I'll see you in just a minute. In this section, we're going to take a look at one more example using streams. This example is going to be much more closely related to what we're trying to achieve back inside that login application we were working on before. So let's take a look at a quick mock-up. Okay, so here's what we're going to do. We're going to show enter your email. Underneath that, we'll show a text input. So a user is going to type in here, and if they type in something that is not an email address, we'll show a validation message right underneath it that says, hey, sorry, but that is an invalid email. Now we're going to use the same rule for valid emails as we did before. Essentially, if a user just puts in an @ symbol, we'll consider it to be a valid email. Not the best validation rule in the world, but it's at least good enough for right now. So if a user enters in the @ then I want to hide that message. Okay, so this is going to be a lot of fun because this is going to be a use of streams that's going to be very closely related to what we're trying to achieve back with that login form. So to get started, I'm going to flip back over to Dartpad. I'm going to clean up the code inside of my main function, and then I'll flip over to the HTML tag, and we'll do a little bit of work over here. So I'm going to add on another H4. I'll say enter your email. I'll put an input underneath that, and then to hold that validation message, I'm going to make a div with a style of color :red, like so. Now I'll close the div off, but I'm going to leave it empty. So a div exists underneath our text input right here, but it by default has nothing inside of it. But if we start to add text, then it's going to show up as red. So eventually we want to essentially get some content inside this div that says something like enter a valid email. That's our goal. Okay, so we're going to have to look at every time a user types inside of here. We're going to have to somehow process that, and then if it's invalid, add some text to the div. So let's get to it. I'm going to flip back over to the Dart tab, and I'll first begin by using the HTML library to get a handle on this HTML input element. So I'll make a HTML element. We're going to call this thing input element. I'll give it a name of input, and that's going to come from query selector input, like so. Now we're going to also eventually need a reference to the div right here so we can add some text inside of it. So I'll take care of that right now. I'm going to get a div element. I'll call it div. I'll be query selector with div, like so. Now, just so you know, to add text into a div, we can write out div.inner HTML. Notice the capitalization on inner HTML here, and we can just set that equal to some string like enter a valid email. So now if I run this, we'll see in red underneath the input, yep, there we go, enter a valid email. So just so you know, that's how we add some text inside there. Okay, so now we need to somehow hook into this input and watch for every time a user types a new letter into it. So to watch for input from a user, we're going to write out input.onInput. So just like the onClick thing tied to the buttons we were working with previously, onInput right here is a stream of event objects. And this event object describes the event that just occurred, or kind of what the user just typed into this input right here. Now to get started, let's try just console logging out this event object that comes through and get a better idea of what we're working with. So I'm going to add on a listen. It's going to receive that event object, and I'm just going to print out this event thing. So let's try running this and now seeing what happens when we add some text into the input. Okay, so notice how my console is empty right now. If I go back over to my input over here and start typing, I get instance of event. So this event argument right here is of type event. If you come from the world of JavaScript or web development at all, you might know that to get the actual value of the input right here from an event object, we reference event.target.value. So this right here, this is not a Dart thing at all. This is a normal JavaScript and web development kind of thing. To access the value of the input right here, we reference the target.value property. Now you'll notice that we get a message down here saying that the getter value is not defined for event target. So this is something we haven't quite spoken about just yet. When we get values through a stream, technically these values are typed. But this is something that's way more closely related to the HTML side of Dart, which is not relevant for us because we're really just concerned with Flutter. So to fix up this error message, I'm going to mark the type of event right here as just being dynamic, which essentially is going to tell Dart just like, hey, don't worry about the type issues here, just do your job. So if we now run this and try it out again, I'm going to type something in here, and then you can see, yep, we get the text out here. And you'll notice that for every event that comes through our stream, we see the entire value of the entire input. Okay, so good progress. Let's take a quick pause right here, and we'll continue in the next section. In the last section, we wrote out a little bit of code to watch this input element, and every time a user adds some input, we are calling listen right now, and just printing out the value of the input itself. Now the way in which we're going to work with this value and validate it is actually going to be almost identical to how we put together our cake factory before. Notice how inside this event object right here, the event object has a ton of data tied to it probably, but you and I only care about the property of event.target.value. And so that's actually very similar back to our factory. Where's that diagram? Come on, right here. So back in our factory, when that event or that order came into our stream, we had the order inspector that said, I don't care about this whole big object. All we care about is that type property. And so it's very similar to the situation we are now in. We don't care about the entire event object. We just care about the target.value property. So we're going to first add on a map function to that stream, and we're going to strip out just event.target.value. So back over here, I'm going to remove the .listen statement because we now have a better idea of what we're actually working with here. And I'll replace it with map. So this will be called with the event object. And from here, we're going to return event.target.value. So now we're just working with that singular text value out of the input. Now, the next step we're going to want to do, we're going to want to look at that value and decide whether or not it is an email address. So does that sound kind of familiar at all? Kind of like some validation of sorts? Well, that step is actually identical to this cake step we had over here. We want to look at the value of whatever we just got back from the map function and we want to either say, okay, yep, this looks good, or we want to raise some sort of error. And so we're going to, again, create a stream transformer that's going to look at that incoming value and then either just add that value back into the stream or add in an error message instead. So back over inside of DartPad, I'm going to, again, make a stream transformer object. So I'm going to declare a new variable. I'll call this thing validator, because that's pretty much what it's doing. It's validating to make sure that we have a correct email address. I'll do new stream transformer from handlers. And then inside of here, I will pass in the named value or named property of handle data. That's going to be a function that gets called with not necessarily our event per se. Probably not the best thing to put it on there. We'll say this is something more like input value, because that's what it now is since it's gone through this map function right here. And then as a second argument, we'll receive the sync. So now we'll look at the input value and we'll say if this contains an @ symbol, then great, let's take the sync and add the input value back into the thing. Everyone's happy. Otherwise, we'll look at the sync and we'll add an error and say enter a valid email. So now if you do not properly add in an @ symbol inside the input value or inside of this actual input right here, then we're going to add in an error message to the stream instead. Now you'll notice we got the red underline right here. It's because we have not correctly imported the async module from Dart. So at the very top, I'll add on import Dart : async, like so. And then I should see those errors go away. Okay, so now let's make sure that we wire up this validator to our stream. So after we do the mapping step, I'll add on a transform. And I want to run everything that comes through our stream through this validator transform. Okay, looks good. Let's take one more pause. We'll come back in the next section and we'll wire up the last step, which is going to be our listen function. In the last section, we added on our validator to check to see if the input value right here actually contains an @ or not, which is how we're going to decide whether or not we have a valid email address. We then hooked up that entire validator with the transform function to our stream. So now we're ready to chain onto this thing with one last step. We're going to add on our listen function. So as usual, this listen function has a first argument that is called every time that we get some data that comes all the way through our stream. Now, if a value comes all the way through our stream without causing any error or anything like that, that means that the user must have entered in a valid input. And in that case, we don't really want to do anything at all. So for the first argument, I'll just pass in an empty function. Or alternatively, we could add in a function of something like print that email looks valid. Now you'll notice we've got the red underline here. It's because our transform function is passing along the final input value right here. So we do need to receive that as the argument to this function. Otherwise, you'll see down here, the message essentially says that we are trying to define a function that is going to be called with something, but we've not actually received that argument. So inside the argument list, I'll just receive that thing as input value, but we're not going to really do anything with it. So then if anything went wrong with the validation, we added the error message. And so we can watch for that error message inside of listen by adding on the name parameter of onError. So this will be called with our error message. So we're going to take that error message and stick it into the div that is placed underneath the input. And remember, to change the value of that div, we say div.inner HTML equals error, like so. And that's pretty much it. So let's run this and see what happens. Okay, so we're going to enter our email. If I start typing in, I'm being told, hey, that's not a valid email. But as soon as I start to add in an @ oops, we forgot one step. My mistake. So we do want to do something right here. So if we successfully get a value all the way through the stream, we do want to actually empty out that div in case there was an error message previously. If you look at the console right now, we are seeing the email looks valid message. my mistake, totally forgot we need to actually empty out the div if a value goes through successfully. So rather than printing that message, let's just do what we're supposed to do. We'll say div inner HTML equals empty string, and that will clear out the div. All right, let's try this again. So after the refresh, we can now type something in. We get the validation message. But then as soon as we enter in the @ symbol, that's better. So we now have a valid email address. And of course, if we go back to an invalid email, well, then the validation message appears again. Okay, so that's it. That's how we can use streams to validate an input. Now, I want to again kind of reiterate the benefit of using streams here. We can very easily add in additional transform steps to this thing. So our current validator right here just checks to see if we have an email address inside of here. And so maybe we should have named the validator like something of validate email or something like that. So I'll change the transform name. If we wanted to have other validation steps in here as well, we could have just as easily added on additional transforms of something like validate, I don't know, not Gmail address if we want to keep people from entering in Gmail addresses. And then we could write an appropriate transform for that. We could do something like transform with validate, I don't know, not blank. Make sure they actually entered an email at all. And so if we put together these additional validators, we would just chain them into this validation step right here, and we'd be pretty much good to go. So we've now spent a pretty good amount of time looking at streams and getting a better idea of how they work. So now that we've got some reasonable understanding of streams, let's take a quick pause. We'll come back to the next section, and we're going to start to revisit that login screen application. But we're going to build it this time around using that block pattern along with streams. So quick break, and I'll see you in just a minute.